She was finishing nursing class and came out of the building. She's an EMT, and they had got a call for a code, and she raced to her car and tripped on the curb and went down, and some lady picked her up and took her to the hospital because she couldn't drive. So, all right, this is worksheet 8 for you who are listening to the recording. I have already done this example, which you have worked out on your paper. Take a minute to look this one over. Someone can pause the video. And again, it's worked out on your paper, but try this. Can someone type ln of 2 real fast so we can put a decimal up here for them? Okay, so the two solutions are here and here. You can skip A if you want. I showed it. B, we didn't finish and get in a decimal, guys. You could have also done 8x plus 1 equals, and then just typed ln of 7, 1.9459. Does that sound right? And then what? Subtract 1 from that. Divide by 8. Shoot. Anybody have an answer down as a decimal? 0.1182? Approximately. Anybody? ln of 7 minus 1 and then divided by 8. Okay, all good. All right, then
I did that one.
Hawken did number 1 here. Number 2 is a little bit trickier because I can't make 8 a power of 4, yes? What? I'm going to have to make these both powers of what? Powers of 2. All right, let's start by writing this as 4 to the negative 1. And this one over here as 8 to the negative 1. All right. So now what do you want to do? We can multiply, so we'd have 4 to the negative 2x plus 1. You're distributing that negative 1. And over here we have 8 to the negative 11 plus x. All right, but there's still not a common base.
Now we can do, the base would be 2.
Okay, so this one would be a 2 squared.
Yeah.
All right, so now we can get rid of the bases as long as we do what up here? Multiply. 2 times negative 2x plus 1. And you didn't have to do it that way. I was just trying to make sure everybody understood where the negative came in. Equals, over here we have 3 times negative 11 plus x. Okay, can you do the algebra, guys? I don't have much room. I'm going to do some of it in my head. Did anybody get 5? I got 5.
Yep.
So I have 1/4 to the 9th. If I put a 5 over here, equals 1/8 to the 6th. That's disgusting.
Bless you.
Yeah, you get negative 18. It does check, so it is 5. All right. You want to try this one on your own?
Yes.
Powers of 2 again?
Yep.
Pretty easy one. Well, I probably would have got it wrong. It's 1/2, isn't it?
It is.
I probably would have put 2. I don't know about you guys, but I always get those backwards. So I try to skip steps. Yes, no, confused. Did I skip too many steps? Courtney? You're okay? All right. All right. We did one of these as an example, and it's not on the recording, so I'm going to take my time on this one. But what we did was we said this is 2e to the x squared, which would make it a 2x up there, right? This is 12e to the x minus 54. And then we just said, well, e to the x is confusing us, so let's call this 2u squared plus 12u minus 54 equals 0. And I only use u because in upper level math, they call it a u substitution when you replace this. I am not going to be here to fix that test. Abby maybe broke her ankle. I have to leave in a few minutes and go to the hospital. So,
Got into an accident or something?
she was leaving class and she had an EMT call to go to, and she was rushing and she popped her ankle bad. So someone picked her up and took her to the hospital. So
You want to go now because I'm
no,
free.
but if you no, I'm going to finish because I'm recording the lesson. If you see Ryan, he's the only one with 5th period off. See if he wants to do my 5th period. He can play the video that I'm recording, okay?
I will do that.
Thanks. All right. Oh, we could have divided that all out by 2, right?
Yeah.
Let's do that. Did you do that already? And factor it? What are you waiting for? You don't need me. How's it factor?
Looks like it's problem 9 and -3.
Good job. So if we solve that, we get u equals -9 and u equals 3. But we can't, there was no u in the question, guys. What do we have to do? Yeah, we have to make u back into a e to the x. Yuck. E to the x equals -9. Oh, I can't write that. Oh, big mess.
Ooh.
7th period is laughing because I do this every day when I record in their class. I'm always screwing it up. E to the x equals -9 or e to the x equals 3. To solve for x, we need to take the log of both sides. Can we do -9? We can't take the log of this. If we tried to do ln of -9, it doesn't work. So our only answer is going to be here. When we take the log of both sides, we get x equals the natural log of 3, or approximately, anybody? Close enough? Yeah. 9899. All right. There is a suggestion here, guys, that you could also do this in your calculator. You could graph this and set it equal and find the zeros. There's only going to be one. That's why we came up with an extraneous solution here because you can't take the log of -9. So that's a good hint for all of these on a test. If you don't know how to solve them, go to your calculator and solve them by graphing.
So wait, it works for all of them or just like the...
It would work for pretty much anything that has an X in it. Finding an appropriate window can be a lot of trouble.
Zoom fit.
That's not going to help on a lot of these. All right, this one you would have just done the log of both sides. We okay to skip that one?
Yep.
All right, what do we have to do first on this one?
Divide.
Yes. Now, on the quiz, some of you randomly decided to subtract the 2.4 to the other side. That's not the best plan. Because the quiz had one, remember it said like $5,000, 1 plus R to the something became something. And some of you subtracted the 5,000 instead of dividing it, okay? All right, so I have e to the x minus 6 equals, I'm going to leave this for a minute. You can divide it, I don't care. That's a 2.4. What do we have to do to both sides? So we're going to take the natural log of both sides, move this out in front. So we end up with an x minus 6, ln of e, which is 1, equals the natural log of 9.3 divided by 2.4. And then we're going to have to add 6 and we'll be done. So I'm going to type it in now because I was too lazy to do it along the way. 9.3 divided by 2.4, natural log of that, plus 6. I get 7.355.
Yep.
Now, if you go out that many decimal places, if you had rounded earlier in the problem, you would get a slightly different answer, okay? And as long as I can see what you did, it's probably fine. Just try to go out like 3 places. But if that last place is different than my answer, I'll just know you rounded sooner. It's okay. All right, try this one on your own. This is kind of icky because you're going to have ln on both sides. Try this. You can do log. I just don't like writing log. It's extra letter. Does it take a half hour to take a picture? I was talking about the student council picture.
Oh, yeah, Zach's talking about that too.
They've been gone a long time, huh? I'm thinking we should just get some ugly decimals. What do you think?
Let's just go with the decimal.
How about we do 2 times ln 3
2 times 2.197.
equals ln of 6, and then we got to distribute it through here. So 1.792x minus 1.792. All right, now it's just a really disgusting Algebra 1 problem, right? Did I type something wrong?
No.
I got negative 4.425, something like that. Did everybody get negative 4.4 something? All right. I skipped 8 again. By the way, you will get the same answer at the end even if you did log, okay? You might have different work along the way. All right, there's another property that says if you have 2 logs equal to each other and they're the same base, then what they're the log of has to be equal. In other words, if I have the log base 3 of x equals the log base 3 of 4x minus 5, then I can get rid of the log, exponentiate both sides. Does this sound right? Okay. So this is not that kind of question. What do we have to do here? This is a different strategy off your sheet. Do you remember? When there's a single log, what did it say to do? This is off 9A, single log.
Isolate the log and rewrite the sentence as an exponential sentence.
Beautiful. Isolate and then rewrite as an exponent. So, isolate first. What are we going to do? By the way, this is, I like to put the parentheses so that I can remember what's going on. Add 1 to log base 5 of 4x equals 12. Divide by 2 so that the log is totally isolated. Then rewrite. How do I rewrite this as an exponent sentence? Or
5,
you can do a
6.
giant exponentiate it like that. Is that how your teacher did it last year? Okay. It's 5 to the 6th equals 4x, which is what this is going to become because this is going to go away. Okay. So 5 to the 6th divided by 4.
3,900
Yeah, left myself a lot of room to write that, didn't I? Whoa. Oh!
Whoa!
How does this happen to me? All right. Oh, this is a tricky one because some of you are just going to cancel the logs, but does this one have a log? Okay, this is a weird one. Do you remember we talked about the strategy that said combine the logs?
Yep.
There's one that says compact the logs. Yeah, but I think we got to move this over to this side. So we're going to do log base 2 of x minus 6 minus log base 2 of 2x equals 5. Oh, no, add it over to the other side. Sorry, become plus, right?
Yep.
All right. I'm pretty sure I would have asked this question on the test, not the original one, because it's less confusing if they're already on the same side. What do we do to combine these together? Plus means, okay, so we have log base 2 of x minus 6 times 2x equals 5. Now rewrite, how do we rewrite that? This is the base, yeah, 2 to the 5th equals that, which some of you already are distributing that. 2 to the 5th is 32. Whoa, or 33, because my pen doesn't work with my brain, apparently. 2x times x and 2x times negative 6. So we get 2x squared minus 12x. Subtract the 32, divide everything by 2. What will we get? X squared minus 6x minus 16. Factor x minus 8x plus 2. So x equals 8 or negative 2. Okay, it says over here, special study tip. It says it's especially important with logs to check your solutions because you can only take logs over positive numbers, right? Now that doesn't mean you get to automatically throw away negatives all the time. You got to be careful and plug it back in. Because if the question had said 6 minus x, when I plug a negative in, I get a positive, right? But in this case, if I plug a negative back in, I'd have the log base 2 of negative 8, and you can't take the log of a negative number. So we get to throw this away. The only answer for x is 8. The test may say, be sure to check for extraneous solutions on any problem that might have a possible extraneous solution. Okay? We all right? Oh, you didn't even have to write that one down, did you? Okay. What about this one? These are both really easy, guys. What's happening here? 1 log equal to 1 log, so we go Are we okay? No one said anything. All right. What about this one? We can't do the same thing. What do we got to do here? Log base 12 of 2 times x equals log base 12 of x plus 7. Now that we're down to 1 on each side, can we just get rid of them? Or some of your teachers would have said do this, so that this all cancels and this all cancels. I don't care. But I get 2x equals x plus 7, which is x equals 7. Okay. Moving on. Those were really easy. Yeah. This looks long and nasty, but I think we can get rid of the logs fairly quickly. What do we need to do? Plus becomes 16x plus 2 times 20x minus 2 equals 319x squared plus 9x minus 2. Who came up with this mess? All right, we can get rid of the log. Distributing over here, foiling all that together, 320x squared minus 32x plus 40x minus 4 equals 319x squared plus 9x minus 2. Okay, do some shifting around and tell me what you get. I heard an x squared. These add together to become what? 8x. So then if we subtract this 9x, add 2. Okay. X minus 2x plus 1. Does that work? X equals 2 or negative 1. What do you think? Can it be negative 1? If I put a negative 1 in here, I get negative 16 plus 2, which is not looking good, right? So I think it can't be negative 1. So the only solution is 2. And you could put 2 in and check it, but I'm going on. All right, what's going on here? What does the plus happen?
Multiply.
So we end up with the ln of x times x plus 16 on the left. What happens to the right? 8 times x plus 6. Get rid of those. Solve. So x squared plus 8x minus 48 plus 12 and minus 4. Does that work, guys? So I got negative 12 or positive 4. Yeah, negative 12 isn't going to work. Does 4 work? Sometimes positives don't even work if they come out negative when you plug them back in. Yeah, 4 should work. Nothing's coming out negative. All right. Applications. This says, how long does it take 50 grams to decay to 10? So our initial amount was 50. 0.0043T, is that how many zeros are after the decimal, guys? 3, okay. And it's supposed to go down to 10. So first step, we could graph, but we're going to solve algebraically. If we divide, we get 0.2. Take the natural log of both sides, according to Tori. ln of 0.2 equals ln of e to that power, which is going to move out here. And then the natural log of 1, or e is 1, so this goes away. So I need to take the natural log of 0.2 divided by negative 0.00043. And I'm thinking that would be a really good question to get wrong because you lost a decimal somewhere, huh? I would. 3742.88, anybody? What is this? Hours? Years?
Years is wow.
I'm going to round to, it's a half-life or it's a radium decay question, radioactive decay. I'm just going to round to the nearest year. Did someone else get something? 3742.3-ish? Okay. Everybody all right? This one is a Richter scale question, but it says this is the reading on the Richter scale. It's a function used to represent the magnitude of an earthquake. E is the energy in kilowatt hours that is released. Okay, so we're going to find the energy released. We're finding the E. So we have 6 equals 0.67 log of 0.37 E plus 1.46. This is a good question because I feel like we didn't do too many where you had to do what we're going to have to do in a second here. What do we do first? Subtract. 4.54 because you've got to borrow. Okay. Now what? We still got to divide by the 0.67. I don't know, is that going to come out nice? Ew, it's really disgusting, but let's go ahead and write down some kind of a decimal here. 6.776, good enough, equals log of 0.37, and that's a capital E, it's a variable, not base E. This is where I'm thinking some of you get stuck. Yes, this is a base 10 right here, right? So we need to exponentiate, as you learned, or just rewrite, was what I would have said. So we have 10 to the 6.776 equals, and all this is going to cancel, we get 0.37 times E. So type that in and then divide by 0.37. Yeah, it's going to be a big number because this is the amount of energy from this.
Wow. That is a very, very large.
To the 6.776 divided by 0.37. Oh, poo. Okay. 1613608.9 roughly. Did anybody get 16 million something?
Yeah.
All right. Did it give us a label? Kilowatt hours? Everybody okay? All right. I don't know why, but I have one more example. I think you don't have this one, maybe? Okay. What do we do with this plus? So we had log base 12 of 12x times x minus 1 equals 2. Maybe because this is a weird base, what do we have to do to both sides? With a 12, yes? So we get over here 12x times x minus 1 equals 12 to the second power, that's supposed to say. So you know where that came from. You want to distribute or divide first? We actually could divide what out? We could get rid of the 12 and make the numbers smaller. We'd still have an x and an x minus 1 equals 12. So x squared minus 1x minus 12 equals 0. X minus 4. X plus 3. X equals negative 3 or 4. I'm thinking it's got to be 4, yes? Okay, so that was just an extra example. What you need to be working on is all of this. The page 196 has a couple applications, but not a ton. The page 167 is 6 application questions. 37, 38, 39, 40, 41, 42. That's 6 problems, okay? You can use the pink reference sheet on the test. Anybody else have a question? All right, get to work.